Basically, yesterday we have discussed constructor and different types of a constructor. We have discussed that there is something called a default or parameterless constructor. Again, these are two types: system-defined default constructor as well as user-defined default constructor. So, if as a user, if we are not providing any constructor explicitly in our program or in our class, then the compiler is going to provide one constructor, and that constructor is said to be default constructor, right? And the default constructor is going to be public and parameterless, right? The constructor is not going to take any parameter. If you define the same thing explicitly, if if we define the same thing explicitly, right? If as a developer, if as a programmer, if we are creating a constructor in our class without any parameters, then it is said to be a default constructor also. But it's a user-defined default constructor. Then we discussed parameterized constructor. The constructor which is defined by the user with parameter is said to be parameterized constructor, right? What is the use of parameterized constructor? Now we can initialize each object with a different set of values. That is the advantage. Then we have discussed something called copy constructor. Means if you want to copy one object data into a new object, then you can use copy constructor. In the case of a copy constructor, what the parameter of the constructor is going to be nothing but the class type. So what is the class name? That reference type parameter is going to take. Then we have discussed something called a static constructor. Static constructor are basically used to initialize the static members of a class, right? If our class having some static members, and if we are not defining any constructor explicitly, then compiler will also provide one static constructor. That static constructor will take the responsibility to define or to initialize all the static members of our class. But even a compiler provided, it is also we have also the chance to define a static constructor explicitly in our class, right? If we define any static constructor explicitly in our class, then compiler will not provide the static constructor, right? Even though our class having some static members, right? But the point that you need to remember is, if your class doesn't have any static member, then compiler will never going to be provide you the static constructor, right? But if your it doesn't matter whether your class having some static member or not, but the compiler is always going to provide you the default parameterless non-static constructor if we are not defining any constructor explicitly, right? Then we have discussed something called a private constructor. We have not explained that related to private constructor, but what we understand is, if we create a private constructor in a class, then we cannot create an instance from outside the class. But this statement is not completely true. It's partially true. Why it is not completely true? Why it is partially true? And there are many concepts related to private constructor. That is many concept in the sense many misconcept, right? People are thinking something but which is not reality, right? All these things we are going to discuss when we discuss the private constructor, right? That is what we have discussed in our yesterday session. Now, yeah, and we have not discussed any question answer because the time is completed. So if anybody having any questions related to our previous sessions, then they can ask me now. Any questions from anyone? No question for today's session. Okay, let's proceed for today's session. Okay. In today's session, we will discuss why do we need constructor while developing our application, right? So, or basically you can say, what is the real-time use of a constructor, right? See, first let us see, first, give me one. So today we are going to discuss why do we need constructor in our application, right? So every class require a constructor. Why every class require a constructor? Because if you want to create an instance, then the constructor is going to be executed. And once that constructor is going to be executed, then it is going to be initialize the data member of your class. So every class contains an implicit constructor, right? If as a programmer, if as a developer, if we are not providing any constructor explicitly, then compiler will provide one constructor implicitly. That constructor is going to be default constructor or parameterless constructor. And that constructor is going to initialize the data member with the default value, right? So what it means now, with the help of that implicit constructor, or we can say with the help of that default parameterless constructor, which is provided by the compiler, we can create an instance of a class. That is fine, right? So if you don't define any constructor, then an implicit constructor is there, which is provided by the compiler at the time of compilation. And using that implicit constructor, we can create any number of instances, right? We can create any number of instances as per your wish. Then the question that should come to our mind is, why we need to define the constructor explicitly again? Already compiler providing one constructor, which is used to initialize the member of our class, and we can create and we can invoke that implicit constructor while creating the instance, right? Then the question is, then why we need to define the constructor explicitly? Is there any need to define the constructor explicitly? Let us try to understand what is the real-time use, or why we need to define the constructor explicitly again, even though the compiler is going to provide the constructor, right? And this is one of the frequently asked interview question. The interviewer might be asking this question. See, whenever we are creating a class, if we are not defining the constructor explicitly, then the compiler is going to provide the constructor implicitly. Then why and at what scenarios as a developer we need to define the constructor explicitly? This is the interview question the interviewer might be asking, right? Then how you are going to explain? Let us understand. See, please have a look at this code, right? So here we have a class called fast, and in this class, I'm having one private variable. Sorry, I'm having one public variable x, and I'm initializing this variable with value 100. Now, from the main method, I'm creating three instances, and I'm just invoking and I'm just printing the value of x. But in this x, what will happen? Now, for all the three instances, the x value is going to be same. Yes or no?
Yes, of course. Yes.
Yes or no? So in this example, if I'm creating three instances of a first class, and if I'm invoking this, and if I'm printing the x value, then for all the three instances, the x value is going to be same. Yes or no? So let's run the application and see the output. See, here it is printing x. But behind the scene, if you look at the memory architecture, then x is not a single value, right? X having three copies inside the memory, inside the heap memory. X having three different copies, right? And all the three different copies holding the same value. This is the problem, right? If we are using the default constructor, then it doesn't matter how many instances we are going to be created. All the instances are going to be created with the same value. That is the problem. You understand now what is the problem? Because the problem is that with default constructor or with parameterless constructor, it doesn't matter the number of instances we created. All the instances are going to be created with the same set of values. In this case, we are having only one variable called x, but if we are having number of variables, then all those variables are also going to be created with the same values. It doesn't matter the number of instances, right? So if we define constructor explicitly with parameters, right, then that means if we are going for parameterized constructor, then as a user, right, as a programmer, we have a chance of initializing all these members with a different set of values for each instance, right? That means while creating the instance, if we have the chance to provide some values, and if those values are going to be initiated with the member of the class, then this is a good thing now. So that means if we define constructor explicitly with parameters, then we will get a chance of initializing the fields or variable of the class with a new value every time we are going to create the instance of that class. Now, Now please observe this example. Okay. So in this example, we have two classes, first class and second class. And you can see inside the first class, we are initializing x with 100. Inside the second class, we have not initializing the x value, we have not initializing the x value at all, right? So that means, so we have two classes and those two classes doesn't have any constructor. That means the compiler is going to provide you the default constructor. The default constructor is going to be a parameterless. The default constructor is going to initialize the data member with the default values, right? In this case, what is the default value? Can anybody tell me? What is the
100.
default? 100. And in this case, what is the default value for x?
0.
0. That means it doesn't matter if you create the instance for one time or n time of first class, or it doesn't matter if you create the instance for second class one time or n number of a time. So when you create the first class instance, the variable is going to be initialized with 100 for each instance. Similarly, if you create the instance for the second class, the variable is going to be initialized with the value 0 for each and every instances, right? Now, if you run the application, then for these three instances, three copies of x variable will be available. And for the second class, again, three copies of x variable will be available inside the if memory. And all those memory locations are going to be default value, right? Default value in the sense for first object, for class first, right? For F1, F2, F3, x is going to hold the default value 100. And for second, right, for S1, S2, and S3 object, again x is going to be, again in the sense it's a different copy altogether. This x and this x both are different, right? The x is going to be the default value 0. Now if you run the application, then you will see that 300 and 3 zeros will be printed on the console, right? Now if you look at the memory location, okay, so this memory location is for F1. Similarly, another three memory location will be created for S1, S2, and S3, and those are going to hold the value 0, 0, 0. Is that clear?
Yes.
Okay.
Yes, sir.
Okay, fine. Now, what my requirement is, now I want x value to be different under the three instances. Value, what value, I don't know, right? I want the x value to be different in three instances, right? Whenever I'm creating the instance of the second class, right, I want the x value to be a different one, but what value, I do not know, right? That means I will come to know the value when I'm creating the instance only. Remember one thing, whenever we are creating a class means we can reuse the class and we can create the instance whenever and wherever you want. So basically, so in our OOPS concept, we know we discussed that there is a issue. There is an issue with the modular programming approach. What is the issue? Reusability. You cannot reuse the things wherever and whenever we want. And we can address that reusability issue by using class and object, right? Class and object means what? Once you create a class, wherever and whenever we want, we can use that class. How we can use that class? Just need to create an instance, and once you create the instance, then we can invoke the methods and the properties or whatever we want, right? This is nothing but code reusability, right? So in future, whenever I'm going to create an instance of the second class, I only need to send the value for the variable x, right? See, so what it means, now whenever and from wherever I want to create the instance of x, instance of the class second, I want to pass or I want to provide the value for the variable x. And that value, what I'm providing, that should be stored inside the x memory location. And for each instance, right? If I'm creating the second class instance three times, then three different values I can provide, and all these three different values are going to be stored inside three different copies of the x variable. This is the scenario where you need to go for user defined or explicitly parameterized construct, right? So you understand why when we are going to define the parameterized constructor in real time. In real time, if you want, when I'm going to create the instance, as a user, I need to provide the values to be initialized the data members. Then in scenario like this, we need to go with parameterized constructor. Now you can see in this example here I'm writing integer x, right? And so this is the this is your public variable, right? Or you can also declare this as a private. That is not matter. But what is public, what is private, what is protected, we have not yet discussed. So let put let make the thing simple. Put public everywhere so that we can access from everywhere, right? So this is a variable x, and this is a variable x. What is this variable? This is your class variable. And what is this? This is your local variable. We'll come to this point. What is class variable and what is local variable, right? To understand this, okay. Okay, let me copy the code. See, this is okay. Forget about this class. Come to this class, second class. So now the second class having one constructor. This is a parameterized constructor. That means when I'm going to create the instance of this second class, this constructor is going to be invoked, right? And this constructor taking one integer parameter means while creating the instance for the second class, I need to pass one integer value, and that integer value will come and sit in this x variable, and we are assigning this x variable to this x variable. Now what is a local variable and what is a class variable? See, this variable is declared at the class level, right? Whenever you declare a variable at the class level, that variable is said to be a is said to be a class variable. And whenever you are declaring any variable inside a block, inside a method or constructor, suppose here I'm declaring integer y equals to 10. So this y is going to be a local variable, and the scope of this y variable is within this block. So you understand now what is a local variable? So local variable means that is going to be defined inside a local inside a method or inside a constructor. So in this case, I'm declaring y inside a constructor, means it's a local variable, and the scope of the local variable is within this block. You cannot access this y from outside the this block. So for example, suppose I'm creating one method, right? I'm creating one void some method, right? Inside this some method, you cannot access the y value. You cannot set or you cannot access y, right? But you can access x. X equals to, you can assign some value. That is possible, but you cannot access y. Why? Y is a local variable. Local variable means the scope is limited. In which block it is declared, you can access inside that block only, right? But here, this is a public variable, right? This is a class level variable. You can access that class variable within the class from anywhere, any block you can access it, right? Like this, it is a local variable. The parameter what you define inside a class are also going to be local variable. Like this y here is a local variable, right? Y here is a local variable. Like this, x is also going to be a local variable. So the point that you need to remember is whenever you declare any variable as part of the parameter, so parameter sense there can be two scenarios. Either in a constructor you can define parameter, or in a method you can define parameter like this. So in a method also you can define parameter. So this parameter or this variable declaration are going to be always local. Local means you cannot access this from outside the class. See, suppose here I am declaring some variable z, right? I cannot access z here, right? I cannot access z, right? But the class variable you can access. You can access x within this block. You can access x inside this block, but this x is a local variable. So how you can say that this is a local variable? To make you understand, so what I'm going to do, I'm selecting this. Okay, so I'm selecting this one. So once I select this one, see this x is selected or this x is selected. The line number 11 x is selected or line number 14 x is selected. 11 means it's a class variable or local variable.
Class variable.
Okay. Now observe this one. If I'm selecting this one, which variable is selected? Line
14.
number 14 means it's your local variable. right? So don't be confused. This dot x means it's going to be your class variable, and whenever you are writing simply x, it means it is going to be your local variable, right? So what we are doing here now, whatever the value coming, so I'm just assigning that value with the class variable. So this dot x means it is going to be your class variable. Is that clear?
Yes.
Okay. Now observe. So for the first class, we do not have any explicit constructor, means all the three instances are going to be created with the value 100, right? For the second instance, right? So whenever I'm creating the instance for the second class, so this new keyword is used to allocate the memory, right? So it will check how many data types or how many variables are there inside the class and what type of variables are there, and accordingly it will allocate memory, and it will give the name that this memory location name is x. And when this constructor is going to be execute, first of all it will initialize the variable with the default value, and then this body, this constructor body is going to be executed. So here I'm passing 100 will be stored inside this variable, and we are assigning that 100 to this class variable. Second instance, I'm passing 200 will be stored inside this local variable, and we are assigning that 200 to the class variable, and same for the case for 300, right? So for the third instance, we are passing 300. So 300 will be stored inside the class variable. Now, if you run the application, you will see that for the first instance, all are going to be 100 because there is no default constructor. So there is no parameterized constructor. But for the class 2, that is second class, all the instances are going to be created with different set of values. Is that clear? Now, if you look at the memory diagram, then you will get a better idea. So total, how many instances we have created in our class? 6. 1, 2, 3, 4, 5, 6, right? 6 in them. In class 1, we have only x variable. And in class 2, we are also having x variable. That means the x variable for class first, 3 copies are available, right? You can see for class first, 3 copies of x is available or not. But all these copies are having the same set of values, that is 100. And for the second class second, again, 3 copies of x is available, but this time, these 3 copies are having different set of values. How it is possible? Because of the parameterized constructor. Because of the parameterized constructor, while creating the instance, we are providing the value explicitly. And what value we are providing at the time of object creation, that value is going to be stored inside this memory location. Is that clear?
Yes.
Okay. So when we define a class, first identify whether the class variable requires some values to execute, and if they are required, then define a constructor explicitly and pass value through the constructors, right? So whenever you are creating a class, so you need to define. So suppose this is my class. Is it required to initialize this constructor explicitly through the user given values? Yes, it is required. Then only you need to define the constructor. In this case, you will see whether it is required to initialize this x variable with the user given values at the time of object creation. No, it doesn't require. Don't use the constructor, right? That means if you want to initialize this variable through the user given values or through while creating the instance with a different set of values, then only you need to go for parameterized constructor. Is that clear?
Yes.
Okay. Now we will see some real-time example of each kind of constructor, right? So let us see this one. Okay. So in this case, you can see I'm having one employee class, and this.
Sorry.
Okay. So in this case, you can see this employee class having some parameters. Sorry, some variables, 5 variables, different kind of variables. And if you decided while I'm creating the instance, right, when I'm creating an employee. So while I'm creating the employee, suppose in my organization, 10 employees are working. Is this possible that all the 10 employees having the same ID, name, address, and everything is same, going to be same? No, it is not going to be same. So while I'm creating the employee details is going to be varied. So as the employee details is going to be varied, that means we need to define one constructor so that while creating the employee, is user have a chance, right? We can provide different set of values for each employee, right? So you can see This employee constructor taking 5 parameters, and using those parameters, we are assigning the variables, right? So you can see here, if I selected ID, it is selecting this ID. That means this ID is nothing but your class variable. And if I'm selecting this one selected, right? Even though this ID, why it is not required to write this keyword here? Because if this is the ID, then the compiler is going to be confused, right? Which ID I'm referring to this. The compiler is only confused when I'm using this. So you will get a confusion. Assignment to same variable. Did you mean assign something else? So he is getting confused. Why? What variable we are assigning to whom? Because your local variable is ID and your this variable is ID. So in this case, you can see this local variable is pointing to, right? But if you want this ID to pointing to my class variable, then you need to refer to this as a t.id. Is that clear?
Yes.
Okay. So it is always a good practice to refer the local variable, so refer the class variable using this keyword. Even if and at what scenario this is going to be a mandatory thing. The scenario like this, if both the local variable and the class variable having the same name, right? In this case, this is having the same name, then you can see this is the color of this operator is something deep. In this case, the color of this operator is not deep. So what it is doing? Now name can be simplified. So what name can be simplified? Remove this qualification, right? Why? Because it is already pointing to this one. Now, why you are going to use this? Yes, if your variable name is going to be s, and if your local variable and class variable is going to be s, then you need to refer this variable using this one, right? You understand? It is not like that. You are going to always use this word. This is not the case. What is the case? If your local variable and class variable are going to be same, then refer the class variable using this keyword, right? Then you can see here I'm creating two instances, one employee 1 and employee 2, and while creating the instances, I'm passing the values, right? So these are the values. These are, you can see, the dynamic values which we are passing at the time of a program run, right? So while running the application, this value will be passed. Even here I am hard-coded the value, right? You can see here I'm hard-coded the value. Even though hard-coded, so you have chance, right? So whenever you are running the application, you may take the value from the console application or not, console or not. So you will declare some variable and you will ask the user, hey user, please enter the ID, enter the age, enter the name, enter the address, enter whether it is a permanent employee or a temporary employee. So you can also take the input from the user, and those input you can pass to this construct, right? So this is the use of, this is the real-time scenario where you need to go for parameterized constructor. Is that clear?
Yes.
Okay, fine. Then another copy constructor, real-time example, same thing. Same thing. Copy constructor we have already discussed. What is the use of a copy constructor? Copy constructor is basically used to copy the existing object data into a new object, and we have already discussed. So this is a parameterized constructor, right? When I'm creating an object and if I'm passing 5 parameters, then this constructor is going to be created. And this is your copy constructor. Copy constructor means the parameter type should be same as the class type. So you can see class name is employee, so the constructor type is going to be employee. So in this case, this is your local variable, right? emp.id. So if you select emp.id, right? So this emp is selected, and when I'm selecting id, so this id is going to be selected, right? So whatever value stored inside the local variable id, we are storing that value inside the class variable id, and class variable is going to be part of your object, right? So id, age, address, name, permanent. Okay, fine. So now you can see while creating the instance, I am using this. So when I'm passing 5 different parameters, so which overloaded version of the constructor is going to be executed? This one or this one?
First one.
Right? And when I'm creating another instance using this overloaded version, So in this case, this overloaded version of the constructor is going to be executed. And what is this U1? U1 is an existing object. And what U1 holding? U1 holding these values, right? And then what we are doing? Those values we are assigning to this ID. That means in this case, even though E1 and E2 are two different object means the memory allocation of E1 and E2 are different. Even though the memory allocation for them are different, they are going to hold the same set of values. This is the use of copy constructor. In real-time application, suppose you have one object and you don't want to do any kind of changes to that existing object. Rather, what you want to do, you want to create a new object with the same existing data, and then on the new object you are going to do some kind of changes. Then in scenario like that, you need to go for copy constructor, right? What is the advantages? The advantage is that there is no chance that the data is going to be mismatched. Whatever data your constructor, your existing object, those data as it is going to be stored inside the new object, right? Is that clear?
Yes.
Yes, sir. Just one doubt, like, is there any real world scenario where this can be used, copy constructor?
Sure. See, suppose this is one real-time scenario one, right? And this data is already stored in the database, or you can say it is one your existing data, and you want to do you don't want to do any kind of changes on this object, right? Rather, so in this case, you want to do suppose some salary column is there, right? Or you can say some salary you can consider, and you want to change the salary of, and you want to check what is the actual salary, or what is the if I'm giving some bonus to the salary, right? Then how we can provide, right? So you can do the changes on the new object only, right? So this is an existing object, somewhere you got the data and you want to update the data. Suppose the name is this Pranay, and you want to do, say, you want to update the name. How you can update this? If you update this one, so it will update your existing. So you want to update this one, e2.name, right? So e.name, I'm writing Pranay updated, right? Pranay updated. Now what you can do is you can store both the data in the database, right? This is your old data, and whenever you are storing E2 means it's your updated data, right? So your database having both the information. What is the initial information and what is the updated information? Later, if you want to check, if you want to check what is the old data of this employee, right? You can see this is the old data. Suppose some salary field is there, right? Let me add some salary, right? Some salary field is there. Then what I'm doing, I'm just passing some salary, integer salary. That I'm doing salary equal to salary, right? And I'm passing salary as 1 lakh, right? So this object is going to be created with salary 1 lakh. But you want this is the old data. Now you want to update the salary. Update salary means I can update to salary is not accessible. Why? We need to make it public. Okay. Public in salary. Now what I'm doing, I'm making it salary as 2 lakhs. So now you can store both E1 and E2, right? Every information is going to be same, but except you have updated the name and salary, right? Now later if you want to check what is the actual employee data and what is the updated employee data, then you can easily find that both employees are having the same data except some piece of information. Now if you want to create a different object, you might have some confusions, right? What should be the ID value, what should be the age? So every information you need to provide. That is also possible, but providing every information and just updating the information is better, right? So if you want, you can create a new instance like this, right? So you can create instance like this. You can see Pranay updated and the salary is like this. That is also possible. But see, in this case, we are just updating what we need to update. But in this case, we are not updating, we are providing every information, right? Even we want to create the same object, we are providing all information. But in this case, we are not providing all information. We are just taking the existing information and we are just updating the data, right? Now we have the same employee having updated information and old information. So you can easily identify what is the previous name and what is the updated name and what is his previous salary and what is its updated salary. Is that clear?
Yes, yes. Thank you.
Right. Then we have something called static constructor, right? So static constructor is basically used to initialize the static data member of a class, right? So you can see static data member of a class. Even though static constructor is there, right? In reality, we are not going to use the static constructor, right? I never used a static constructor in any of my application, right? Because no a requirement not come. But if you want to execute some piece of information only one time, when the class execution start, then you need to put that information inside the static, right? And inside a static constructor, you can initialize the static data member, right? Suppose here I'm declaring static int j. I have not initialized it, and I'm initializing that j here. And this initialization statement or this static constructor is going to be executed only once in its lifetime. So if it is going to be executed only once, and this constructor is going to initialize the static variable for the only one time, then why I'm going to create a static constructor? I can directly initialize this at this level now. So once I initialize this constructor at this class level, then the compiler is going to provide the static constructor, and that static constructor is going to initialize the static member, right? So the point that you need to remember, if you want to execute some piece of information, that information means that might be the object initialization statement like this, or some other information like this, only one time, then you need to go for static constructor. And even I never used any kind of static constructor in any of my real-time application, right? Even I use static classes, which is going to, we'll discuss in our coming session, but I never use static constructor. And you will never find any kind of a static constructor in your application also, right? So frankly speaking, I do not have any real kind of scenario where I can use the static constructor, right? But if you want to execute some piece of information only one time, then you can put that information inside your static constructor. Is that clear? Yes or no?
Yes.
Okay. Now let us look at this program. See, here I'm declaring one integer variable I, and I'm declaring one static variable j, right? This is a non-static, so it is not created using the static keyword, means it is non-static, right? And this is going to be your static, right? And here you can see, okay, now let's say, now let us observe the output, how the output is going to be, right? So this is static, what is the variable? Static I, right? So when we create, so see, when your class execution start, right, from where the class execution is going to start? From the main method only. But before executing the main method, first of all, it will check, is there any static constructor either defined by you or provided by the compiler? Yes. In this example, we have a static constructor. So before executing the main method body, it will execute this. So in the output, first this statement will be printed, right? In the output, first this statement is going to be printed. And after printing this statement, what he is doing is initializing the j variable with 100, right? You can initialize like this, or you can even initialize like this. So static j is going to be your 100, right? Then you are creating an instance of E1. Now come to the E1 section, right? So this is instance of E1, right? So you are creating an instance of E1. So this is your example constructor. So this constructor means This is going to be your example constructor. So this statement first executed, and then it is initializing the I value with 100. So then this statement is going to be executed, then it is going to initialize the I value with 100. Is that clear? When these two statements, yeah, then what I'm doing now, we are just calling the increment function, display function, increment function, and display function. Now, while I'm calling the increment function, this statement is going to be executed, right? So I plus plus, j plus plus. So what is the I value? 100. So I plus plus means what it will become? 101, right? So this is your j. So j plus plus means j also becomes 101. Is that clear? I plus plus j plus plus means you can access the I variable and j variable here. I is your class variable, right? And j is your static variable. You can access a static variable from anywhere directly, right? So it will increment the I value by 1 and j value by 1. So what is the I value? 100. So increment 1, so it will become 100. What is the j value? 100. It will become 101, right? So when we call the display function, so it will print the I value and j value. What value it will print first? It will print 101, and what j value it will print? It will print 101. Is that clear? Yes or no?
Yes, sir.
Okay. Then again we are calling the increment function. Again this block is going to be executed. Again it will increment the I value and j value by 1. So what I value become? I value become 102 and j value also become 102. Now, so when again and again we are calling the display function. So display function means it will print 102 and 102, right? Is that clear? So now, as of now, we have executed this statement. Now we are creating another instance of E2, right? So E2 is going to be executed. So
Sir,
when
I think I equal to
sorry,
yes, sir. I equal to I become not 102. I become maybe 101 also. 101 only.
why?
So because it is not static.
See, okay, let me understand you. Static are only created once, right? This is your static variable. Let's say static j. This is your j, right? This is your j variable, and this is your obj. This is your object e1. What is the object name? e1, right? This is your e1 object. Inside e1, what is there? I is there. Yes or no? Yes or no?
Yes, sir.
Okay. So when the static constructor executed, I value becomes what? J value become what? 100, right?
101.
When the static constructor executed for the first time, j becomes 100, right?
101. 102.
Sorry, why 102? I'm starting the execution. So before
No,
executing the
one.
method, the constructor is going to execute it. So constructor
Yes.
executed means it will initialize the j value to what value?
100.
100. Let's put 100 inside this memory location, right? 100. Is that clear? Okay. So when this constructor execution statement executed, this block is going to be executed. Yes or no?
Yes.
So what it will execute? It will initialize the I value to 100. So I is also become 100 when the constructor is created. Is that clear?
Yes.
Okay. Now, this is your e1 dot increment function. Which function is going to be invoked? This one.
Yes.
So when this function invoked, what will become? I will increase by 1, j is also going to increase by 1, because we are incrementing the I value and j value. But in this case, this increment function called on which object? u1. Yes or no?
Yes.
So E1 object, we are calling the increment function. So in E1 object, we are calling the increment function. In E1 object, is there any variable called I?
No.
Yes or no?
No.
In E1 object, is there, so this is not object, right? E1 object means you need to consider this one. E1 object means this one. Understand na? And in E1 object, you are calling the increment function, means this function will come. So here in this E1 object, is there any variable called I? Yes or
Yes.
no? Yes, I is there. Na? This location, this block is your I variable. It will increase this variable by 1 or not. So this 100 will become what? It will become 101. Yes or no? And
Yes.
then it will increase the j value by 1. J is a static variable. Directly we can access static variable from anywhere. Object is not required. So in this case, j becomes what? 101. Understand? Then we are calling the display function. So while calling the display function, so but remember on which object you are calling the display function. You are calling the display function on the E1 object, right? So in E1 object, you can see what is the I value. E1 object, what is the I value?
101.
So it will print 101 first. And what is the J value?
J value also 101.
So it will print J value 101. Again, I am calling the increment function, right? So when I'm calling the increment function, again, this block is going to be executed.
Yes.
And I am calling this an increment function on which object? E1 object.
E1.
E1 object means this block.
Yes.
In this block, it will increment the I value by 1. So what I value will become?
I will become 102. Yes.
I will become 102, right? And again, it is incrementing the j value. J is a static variable. You can access from anywhere. So j value also become what? 102, right?
That
Then
means the same instance of.
sorry?
Yes, same instance actually. If it is
This
different
is your
instance, then
instance. This j is not
yes.
your instance. This is your instance only. This is a global variable. You can access j from anywhere, right?
Anyway,
This is your class variable. This variable I is going to be created per instance, but j is not going to be created per instance. I will come to that part, right? Again, when I'm calling the display function, it will check what is the I value 102 and what is the j value 102. So 102 and 102 is going to be printed. Now what happens when this statement is going to be executed?
again a new instance. Creating new instance.
Again, a new instance is going to be created. So let's create a new instance, right? What is the instance name? E2. And in this instance, how many variables are going to be created? Only one variable, because one non-static variable is there. What is the name of that variable? That variable name is going to be I only, right? So you can see this is your non-static member. Non-static members are going to be created per instance, but this is static. This is a global, only created once, right? So you can see, so this instance is going to be created. And when this is going to be created, when this constructor call is happening, so it will initialize the I value with what value? What value?
101.
100.
101, where you
10.
call? Where you see 101? See, this is your constructor calling, na? So when you execute this constructor, first this statement will be executed. Then it will execute this statement. When this statement is executed, what value it will assign to this I variable? This right hand side value, na? So what is there in right hand? 100 is right in there, so, right? So and you are invoking, and this constructor is for E2 employee, right? So that means in E2 it will store 100 here. You understood? right? And then you are calling increment function. But this time you are calling increment function on which object? E2 object, right? So once you call this increment function, statement are going to be executed. It will execute the I value for which object? E1 object or E2 object?
E2 object.
E2 object, because we are calling this increment function on E2 instance. So E2 instance means this I value is going to be incremented in E2. So E2 means this value will become, right? So this
101.
value will become 101, right? 101. Now it will increment, then it will increment the J value by 1. So what is the current J value?
102.
102.
102.
Static 102. Yes, static.
Yeah. So what it will become?
103.
103, right? So when you invoke this display function, right, and currently you are invoking this display function on E2 object, right? In E2 object, what is the I value? 101, and what is the J value? 103. So here it will print 101, and here it will print 103, right? Now again you are calling the increment function, and you are calling the increment function on E2 object, right? So E2 object means so you need to check. So this is I value plus plus 1, J value plus plus 1. Now again E2 object, so it will increment the I value by 1. So what I will become? I will
102.
102, right? And it will increment the J value by 1, so J becomes
104. 104.
104. 104. So now if I invoke the display function, it will print 102 and 104, right? 102 and 104. So this is how the variables are going to be created. So static means they are created only once. They are having only one memory location, and you can access the static variable from anywhere, from any object you can access. But for non-static, they are going to be created for instance. See, this is your static variable created only once. Non-static, I 2 instances we created, so 2 copies in the memory available, right? Now if you're on the application, you will see this output. Right, see, first 101